Okay, P-band. I've been asked by one of the members of the P-band about one of the questions that was part of the plotting graphs MyMaths task that you had to do. And I figured it would be much easier for you to understand if I went through it on a video rather than trying to word it out on an email or anything like that. So what we've got here is a set of 6 different functions. Now, this first function is a quadratic function. The next function is a straight line function, dead easy. This one's part cubic, part reciprocal. It's a bit of a mad looking function. This one's the exact one that was in the person's question who asked me a question. This one's a bit of a weird linear reciprocal sort of thing. And we've got some other line functions. Now, what the question was all about was you had some graph, which in this first case, I've got, this is my example one, I've got y equals 3x squared plus 5x minus 2. And we were finding out when does 3x squared plus 5x minus 2 equal 0? Well, this one's really easy to answer. If I just flick that function on, okay, you can see when that function equals 0. That function equals 0 when these things happen, just there, okay? Just there like that. All right, that's where that function equals 0. So those are called the roots of that quadratic, and they're fairly easy to find, really. You can do all sorts of different things to find them. But if you're working graphically, often what you'll just have to do is just read it off the graph. Now, the thing that the person who asked me about this found more difficult was a question that looked a little bit like, it would say like 3x squared plus 5x minus 2 equals 3. Now, imagine you had this side here, and this was y equals that stuff. And this was also y equals that stuff. Then what we're trying to say is, well, if you've got the graph that's on the left-hand side and you've got the graph that's on the right-hand side, where do those graphs give you the same value? So let's take a look. We've got the graph that's on the left-hand side, which was y equals 3x squared plus 5x minus 2. We've got the graph on the right-hand side, which is y equals 3. Where are both of those graphs exactly the same? Where is it where there's an input into each of those graphs that gives you the exact same output? Well, that exists here, okay? I have to zoom in for it. There we go. It exists here at 0.703257 or whatever. If you substituted that into each of the quadratic and the linear, you'll get 3 out. And the same goes here, okay? The solution that you'll be looking to give to that question will be negative 2.37 and 0.70, okay? So not overly difficult, really. Let's take a look at one that's maybe a little bit more tricky just because of the fact that it's got more difficult values in there. I'll just get rid of these things and we'll zoom out. So in this case, we've got this sort of weird looking graph, really mad looking graph, part cubic, part squared reciprocal, a bit of a mad graph. We've got this straight line. When is it that this graph will equal 15? Well, actually, it'll do that 1, 2, 3 times by just drawing across from 15. So if I was asked, for example, to find out when is it that that function, which was 5x cubed plus 3 over x squared plus 1, when does that equal, say, 20? All I'd do is I'd go to 20 and I'd just draw straight across, okay, and I'd find out those 3 particular values, okay, whatever they were for the x value. Obviously, the y value is always going to be 20. You want to find out which x value causes those things. And so if we have a little look at what was expected for the question that the person sent to me on MyMaths, it might well be the same for a lot of you, but it might not be. So what you would need to do is you would have the first graph already drawn. You're expected to know that you need to draw across from y equals 4 and just get 2 general ideas of the solutions. The first one's going to be 0.64 and the other one's going to be a mystery. I'm not going to tell you what that one is. Okay, if you're ever asked about something complicated equals a linear, okay, that linear there will be 4 or 2 or 3 or something like that. Just draw across from there and find out when is it that you can put a value in to the curve to get the output 4. What do you have to plug into here to get 4 out? That's what's really being asked, okay? What goes in so that you get out 4? Well, just give the intersection with y equals 4. All right, hopefully that'll help. Cheers.